First of all, why it is important to understand the data type and formats and their loading. Why it is important, okay, for all of you. So this is a type of a foundational knowledge, okay. So every person who is going to build their career in GIS industry, this is the basic thing that you all must know, how you can load different type of data and different type of formats in QGIS or in any other GIS software that you will be dealing in your future, okay. And so data formats and data types are basically the building blocks, okay, of geospatial information. And before you begin your analysis in QGIS, you need to grasp these fundamentals to work effectively with the spatial data. Spatial data means the data with some geographic information, okay, location information. So loading and visualization is important because it involves understanding how to import data, different data formats, okay. So you need to learn how to visualize layers, symbolize different features, and create your maps, okay. And layers by layers means different sets of data, okay. And efficient data loading will impact always impact your project performance, whatever project you will be working with, okay. So as a fresher, you need to learn these techniques to optimize your loading time. Sometimes there are some process that takes more time to load data, and I will be teaching you all the three methods, okay, from the slower to the fastest method of loading your data, okay. And this way you can also manage the large data sets, okay. And proficiency in the data formats and loading opens like doors for GIS related roles, because this is the basic question that you can be asked in your job interviews, or maybe on in the job interviews or in the future openings, okay. Right. So this is the thing, okay. That's why we are going to learn how to load data types, okay. And today we will just focus on raster data type. Raster data type is can be loaded from various different sources, and that we are also going to discuss today. And what is the advantages of raster data, why it is important, okay, and how is it related, how it is useful for us, and that we will also discuss in the end, okay. So now, as we have discussed yesterday, that we took an example of a painting, okay. I have also given you an example in the presentation. So like that we make a painting on a paper. We discussed its elements. So, what are those elements? These houses, trees, some water, and a man on a boat, or some sky or sun. These are all its elements, right? So, these elements is basically your data, your different data layers. Okay, so one layer is your houses, one layer is your trees, and one layer is your water body, and one layer is your sun, okay, or a mountain. So right now, when you have these elements, you are just thinking about these elements in your mind, okay. But now when you want to execute your idea of drawing some painting, what will you do? You will take a paper and you will start drawing or loading these elements, okay. Drawing is analogous to loading in QGIS, okay, let's say like that, right. So you will start drawing or loading these elements on a paper, or say workspace in terms of QGIS. So QGIS workspace looks something like this, okay. So this is the workspace where everything will be loaded, right. So, yeah. So, first thing, so yeah, we are going to use this analogous situation of drawing a painting to understand the fundamental of different type of data and different formats of data into QGIS interface, right? So first thing first, let's understand some of the theoretical background of raster data. This is also a raster data, but because it is in the form of a picture, Okay, so why every picture is in the raster format? Okay, so every picture that you click from your mobile phones or your digital cameras, they are all rasters. Any picture you see, if you see a PDF, it is again a raster. Okay, if you scan something, this is again a raster. Okay, so let's understand some of the theoretical background of raster data, and then we will see that there are many ways of loading this type of data into QGIS, and we will discuss three of them, as I said. So by the end of this exercise, you all will be able to understand raster data type and formats supported by QGIS, and will be able to create your own first map. So when I say a map, you know that there are different type of maps, from geographical to political to geological maps, etc. Okay, population map it can be, right? But the common thing in each map is the requirement of the data sets, different elements, and a platform which will be a QGIS for us, when you can where you can load and understand and create your maps. Okay, so now let understand each and everything one by one. I hope this painting example is quite relatable for you. Okay, yeah. So now first thing is, what is raster? Okay, so raster data is any pixelated, okay? Pixelated means pixels, it will have some pixels, okay? Or gridded data, okay? There will be some rows and there will be some columns which will make a grid, okay? Right? And where each pixel, if you talk about each pixel, this this black that it has marked, it is called cell, or it is also called pixel. Okay, it will contain some information which will be specific to a geographic location. Okay, so all these different colors, if you see here, see they have taken like zoom in picture, right? If you will try to relate it, then these blue pixels are representing some river like feature, and this is some grassland, or maybe this is some sort of let's say bare ground. Okay, or some sort of house present in this image. Okay, so when you zoom in and you see what this picture is made up of, this is made up of different type of pixels. Okay, these square shaped boxes are called pixels, which contain information. These are the basic element of a picture. Okay, and the value of these pixels can be continuous, like elevation values, temperature values. Okay, you can give any type of information to these pixels, right? And it can be categorical means that it may be it can also contain land use, land cover information. Okay, how land is divided into different type of uses, how a particular land is covered with different type of infrastructure. Okay, so some land use, land cover data can be stored as your raster data. Okay, and we will see it is in our exercise. So if you think this sounds similar or familiar to you, then it is because that this data structure is very common, and this is how we represent any digital image. Okay, so any digital image, or digital aerial photographs, imagery from satellites, if you see, and digital pictures, okay, or even scanned maps, right? So raster formats supported by QGIS are Arc Info Binary, GeoTIFF, and JPEG, LDAS, Imagine, etc. These are different type of raster formats. Okay, so I used two terms here, pixels and grid. So what exactly is their definition, how they are defined? Okay, and what does it exactly mean? So pixel, this is a short form of for this picture element. Okay, we know that this is called picture element. So it is the smallest unit. Okay, it is the smallest unit of raster image. Inside a pixel, there won't be anything else. Okay, so this is the smallest unit. This pixel will contain the information. Okay, and it corresponds to a single square. Okay, single square, or it can be a rectangular cell in the grid. What is grid? This is your grid. Okay, this is your grid. These are all your grids, and these pixel value is present inside the grid. Okay, and each pixel will contain some value, information on maybe color intensity, and maybe temperature, land cover, as I said. Okay, and these pixels collectively form the image when displayed on a screen, okay, or when you print it, right? So the grid defines what is grid. Then grid is the overall structure of the raster. Okay, this is the overall structure. You know how grids are formed. Okay, when your rows and columns are, intersect and the enclosed area, that forms a grid. Okay, and in grid, there can be a pixel and there cannot be a pixel. Okay, but because this QGIS or GIS softwares do not raster, actually do not support blank value, so we have to provide some value at least. Okay, and we will define that value as the no data value. We tell QGIS that this is a no data value, and we have to define that when we are, working with our rasters. Okay, and we will see this in our upcoming exercises, upcoming classes. So next important thing other than cell and grid in raster image, raster storage, is your tiles. Okay, so tiles, you can imagine, is similar to your marble tiles. And in modern times, when we want to decorate or organize our house or offices, we use tile flooring. Okay, so they are different, and all these tiles when combined, they fit into a floor, right? They fit into a floor, or they fit into a wall to and but they are divided, right? They are divided. You can see the divisions in tiles, right? So this is how your Google Maps and your satellite imageries are stored in the internet in the form of a in the form of these tiles. Okay, and so these raster tiles are basically used to organize your world imageries or different type of imageries into a grid of small image tiles. Okay, small image, these are all small image tiles. Okay, so this can be a tile, this can be a tile. Okay, usually when we talk about it, so these tiles are 256 into 256 pixels. Okay, 256 by 256 pixels. But it also supports, sometimes it also accommodates 512 into 512 pixel images. Okay, that means that in this particular tile, there will be 256 into 256 by 256 pixels. Okay, and each pixel can have different spatial resolution. It can be 30 meters resolution, it can be 90-meter resolution. Okay, and by spatial resolution means that this is the smallest object on the earth, on the surface, which our camera, which our satellite, sorry, which our imagery can resolve. Okay, so this is how these images are created using cells or pixels, and grid and tiles. Okay, and that's how, if you zoom in, then you can also differentiate all these things in your images. Okay, so I think this should be clear. So information, if I talk about the information contained in each raster data, can be extracted, and the image can be again, classified, can show us land cover classification and crop health, heat maps, and many more, right? So exactly like all the satellite imagery, Google Maps and other base maps are stored as tiles. In these tiles there are pixels. Okay, so as I said, there are different formats for storing your raster data, such as raster formats. Okay, by QGIS or arc info binary and geotiff. But why do we require all these formats, all these different formats? Why can't we store our data in only one type of format? Because these different formats are differently optimized for performance. Okay, sometimes there are larger data sets, but one particular format is not capable of optimizing that large data set. So you need to prepare one other format which can, tackle the larger data set. Okay, so each format, as can be said, that each format have its distinct purpose. Some prioritize efficient compression, like JPEGs are compressed, right? And if you want to work on the geospatial data, then you have to go with geotiff, because this is a format that have geographic information. Okay, so, and if you want to work on some web graphics, then choose jpegs for it. Okay, so among all these formats I wanted to discuss, and yes, the difference also lies in the way the data is stored. Okay, so for example, if we talk about ISRI's own format, in which most of the ISRI data is stored as raster, this is the format in which it is stored. Okay, so how does it look like? It looks like something like this. Okay, and it defines geographic space as an array of equal sized square cells. If I plot this data in QGIS, if I open this data as raster in QGIS, it looks something like this. Okay, so can you see, these are equal sized arrays. Okay, and each cell stores a numeric value. Okay, that will represent some geographic attribute, again elevation, temperature, anything for that unit space. Okay, for this particular unit space, you can see the cell size is 30. So cell size 30 means it has 30 meters of resolution, right? So this is 30 meter by 30 meter. So whatever data, suppose temperature data, it will store the temperature of this particular area of 30 meter by 30 meter in this cell. Okay, and for next 30 meters by 30 meter area cell size, this will store different value of temperature. Okay, if you see the similar colors, then that means they have same values. Okay, if you think these two colors are same, that means these two will have the same values. All right, I hope, see, can you see, there is 2 and 2, so there will be so many colors that will represent 2, and they will be all similar. Okay, so how does it look like? The basic structure of this ISRI ASC format of will always begin with a header. Okay, this will have header which will give you that defines the property, such as the cell size. Okay, 480 into 450. Cell size means these are the grid, these are the number of columns, these are the number of rows, right? And and there will be coordinates of the origin. Okay, so these are the origin coordinates, right? This coordinates, right? And there will be cell size, there will be no data value. So our this format is actually text based, and you can read it, and I have one example of it with me. So this is the data. Sorry, this is the data. Actually, I plotted in QGIS, and this is the type of grid, that pixelated grid that I got using this particular data set. Okay, so there are two columns. Can you see? There are two columns. There will be 20 rows, and these are the coordinates of x and y. There is 30 by 30 meter by 30 meter cell grid. Okay, and this no, sorry. Yes, yes, yes. Okay, okay. Okay. Can you see it now? Actually, it will be easier for me to compare. That's why I minimized it. Okay, let me increase the size like this. I think it will be okay. Is it good? Is it fine? Okay. Yeah. So this value minus 32768 is your no data value. So no data value, the idea behind this no data value is that it is the way to identify potentially invalid pixels. Okay, so if you have any invalid pixels can originate due to some error while acquiring the data. Okay, and suppose you have the temperature range, and temperature range of any area, and suddenly you saw that in your data, in your like the data that you have, there is some invalid value, like minus 1000 degrees Celsius. Okay, so you cannot delete it. Okay, because rasters can never be blank. So instead, in place of it, you have to provide some no data value. Usually no data values are minus 999, 9999. Okay, so this is huge, this is a standard value which is given to all the no data, because your rasters cannot be, any pixel in the raster cannot, should not be left blank. That's why you are telling QGIS or any raster data that if you find this value, assume this is a no data value. Okay, and we will see how we assign it in our raster exercises. Okay, how to assign this value, I will tell you in our upcoming exercises, right? So yeah, like raster, as I said, raster formats do not support empty spaces. Okay, so you have to provide some support by providing some no data value. Okay, so I think we are done with the theoretical discussion. Do you have any question till here? Anything you want me to be repeated? Sorry, your voice is not clear. No, there is no difference. Actually, these pixels, you make a grid. Okay, you make rows and column and fill those grid with some information. Okay, and that information is called pixel. Okay, so your cell contain all the, every raster data is a gridded data. Okay, and each grid will contain some information in the form of pixels. So this particular cell, this form a cell, and this is called pixel. Is that clear? Yes, yes. Grids are a, you can say, a larger unit. Okay, you say the rasters are either gridded or pixelated. These are like synonymous terms. Okay, so grids are like metrics. Like you make rows and columns. Okay, you make these rows. You have made these rows and these columns, and these rows and columns contain pixels. They form pixels. If you talk about this particular square, this is a pixel, but this is not a grid. Grid is made with complete row, right? With the intersection of rows and columns. Okay, great. Okay, so now let's, I think we are done with the theoretical part. Yeah, so let's go to our QGIS and let's understand how we can load our raster data in QGIS. Okay, I have provided you one folder of D2. We will use one topo sheet in that folder to load our data. Okay, so before you load your data or you start working in QGIS in any new project, make your habit to save your project. Okay, so how you can do that? In your project toolbar, I hope you remember to get how to get these toolbars. Okay, right click here and get your toolbars. Okay, project toolbar. Right, in your project toolbar, you go to this third icon here, save project. Okay, so click on save project and just go browse through your folder in which you want to save your work. Okay, and it has directed me to the same folder in which I want, so I'll just save it, project 2. Just give it a name and click on save. Right. So as soon as you save your project, there are two advantages of it. You say, first of all, your work is saved. Okay, and you just have to, click on this save button every time. And after this, one project home is created for my folder. Okay, in which I will show you how it is important when you are working with raster and vector data. Okay, so first step is to always save your project. Okay, as we discussed yesterday, there if when we want to add any layer or when we want to create any layer, we go to this layer option in the menu toolbar. Okay, so because we want to add our layer, so we will go to layers. We will click on add layer, And what type of layer we want to add? We want to add raster layer. Okay, so click on raster layer. Right. So data source manager, this window will appear. Okay. And you have to click on these three dots to browse through your folder. Okay. So just go back and check where your data is. And when you are inside that folder, click on the click on the item that you want to open, raster file that you want to open. Okay. So I'll go with this toposheet.tif. I have georeferenced this for demonstration. I'll show you how to georeference these images in our upcoming classes. Okay, click on add and then click on close. Right? I hope these steps are clear. So this is the one way of loading your data. So when you zoom in, okay, just zoom in. Can you see these pixels? These are all pixels, okay, that contain some information. What information? If you will if you want to see the information of these pixels, you go to legend and see what does this particular feature represent. Okay, if they have marked it, it should be somewhere here. Yeah, this is something like this. Okay, so this is something to do with the wells, right? So this is how your pixelated values represent. That's why we need a legend to see what type of values are stored. Okay, so everywhere you will zoom in into this picture, you will see these pixels. Okay, and these pixels are actually storing the information. Okay, so when you click your own picture in your mobile phone, if you zoom in that picture, you will see some pixels, right? Depending upon the resolution, right? Yeah, so this was the first way of loading your data into QGIS, right? So next thing is to use data source manager toolbar, okay? And that is comparatively more handy, right? So because you need one more toolbar, you right click on the menu toolbar and click on this data source manager toolbar, right? So you get usually you get this toolbar as a side toolbar. Okay, but you are free to move it anywhere in your screen. You can move it anywhere, right? You can also bring this as your side toolbar. Just hold these dots, vertical dots here, and hold your left mouse button and bring it to your desired position, right? Yeah, so in your data source manager toolbar, you click on these first icon here, okay, and you see the similar window appeared. Okay, data source manager raster, because we have already selected raster. So otherwise, if you're going with this option for the first time, then you have to click the raster here. Okay, again, all the steps are similar. You click on these three dots and browse to your folder, and then click on add and click on close. Okay, so try this step by yourself, and do let me know if you are stuck anywhere, right? And third way, the most easiest way, or the most like fastest way to get your raster and vector data. Mind it, I'm talking only about raster and vector data in this case. Okay, we are not talking about some excel sheet or some csv data, just raster and vector data. Because we have created our project home, right? In project home, you will see this toposheet.tif. Okay, toposheet.tif. Just drag and drop it. All right, just drag and drop, you will find your data. See, you have got your data. This is your topo sheet. Just drag and drop here. Okay, I hope these three methods are clear in your mind, and you will be dealing with this drag and drop option. Okay, because this is the fastest and the easiest way, but there are some exceptions in which um, this won't work. Okay, and we will discuss it, right? So next thing, I have given you one assignment that you have to install one plugin which is called open topography dem downloader. And I have also provided you one youtube video using which you can check how this particular plugin works, okay, and how it is useful for you. Okay, so when you install that plugin, you will find it under the raster option. Okay, and here is your open topography gem downloader. All right. So this tool, please read about it from here. This tool will download DEM for the extent defined by user. If you are working with the elevation data, okay, if you're calculating slope, or if you are doing some analysis like topographic analysis, then you need digital elevation models. Okay, so this is the easiest way in QGIS to get various DEM. Like these many DEMs you can get from directly from QGIS. Okay, so let's download this SRTM 30 meter, right? And you have to define the extent. If you already have latitude and longitude value of a particular of your area of interest, then you can, write it down here. Suppose if you do not have, what you can do, you click on this drop down menu. You can calculate from layer. Okay, any layer that you have loaded in your workspace, that will be shown here, right? Next is your, you can calculate from layout map, you can calculate from bookmark. If you have created any special bookmarks, I'll demonstrate this as well, right? You can also use your map canvas extent. Map canvas extent means the extent which you are seeing in this map canvas. Okay, and it will take the extent of this particular map canvas, and it will download the DEM for you. Okay, otherwise this is very straightforward method. You just click on it, it will take the extent and it will get the data for you. Okay, so I want to demonstrate the map canvas here. I will use this option, draw on map canvas. Okay, so suppose I want DEM for this particular area. What I will do, I will use the left mouse click button, and I will drag my mouse to the extent in which I want the data to be downloaded. Okay, so just drop your left mouse button, and you will see the extents are defined for you. Okay, and you can save your output raster as a temporary file, or using this button here, you can save it to your particular folder. I have already saved it, so I will leave it as blank. Otherwise, here you can give it some name. Okay, and then click on save. Okay, and I will just use this temporary file option, and let's see how it differs. Okay, then click on run. Okay, it's going to take some time based upon the extent of your area, and also, of course, the speed of the internet. Okay, so meanwhile, let's discuss. I think it's done. Yeah, on close. Yes, so this is your digital elevation model for this particular area, where elevation values varies from -11 to 66. Okay, so this is your maybe some values are, in the negative elevation. Negative elevation means maybe it represents some sea or some depressions. Okay, because it is in the Chennai region, that's why maybe some of these values are negative. Okay, yes. So what is digital elevation model? Digital elevation model, it represents the bare ground. Okay, bare ground. Okay, let me also get the OpenStreetMap for your reference, which can be found in browser panel under XYZ tiles. Okay, we discussed about the tiles. What are tiles? So OpenStreetMaps are stored as tiles. Okay, so let's get this data, and just hold the left mouse button to drag it to the bottom. Okay, right? Yeah, I'll close this topo sheet, and this is the area. Okay, area of our interest for today, and which is in near Chennai. You can see some traces of the river as well. Okay, yeah, so what was DEM? So it is a representation of, as I said, bare ground or bare earth, topographic surface of the earth. It excludes, what it excludes, everything like trees, buildings, or any other surface object. Okay, you won't find elevation of all these things. If you want the model, elevation model, which can include these natural and built feature, such elevation models are called DSM. Okay, digital surface models, which these DSM, it captures like elevation values from the top of the buildings, tree canopies, power lines, and other objects. Okay, if you want to see the difference between DEM and DSM of a specific area, just go to Open Topography DEM downloader. Okay, and from here you can also get this DSM, which is provided by Copernicus Global DSM, which is of 30-meter resolution. Okay, so just try this, download this, and identify the difference between the two. And because DSM includes natural objects and buildings, etc., and it captures the elevation from the top of all these surfaces, not the actual ground surface. Okay, so that's why when you're doing some topographic analysis, you need DEM, not DSM, right? So I hope this is clear. So special resolution of these DEM is 30 meters, right? So this pixel value, this elevation value represent the average of pixels, average of elevation in 30 by 30 meter of the ground surface. Okay, so yeah, so this was the, and this is stored in the form of geotiff. Okay, and your topo sheets are JPEG format. It's stored in JPEG formats, right? And this is when you download it. This is in the your TIFF format, geotiff format, because it has got this geographic location. But every raster will look like they appear in the pixelated and the gridded form. Okay, but the way they store information is different from one to the other. So this is the basic difference, right? So the thing is that all this data, right, if I talk about these topo sheets and this DEM, all this data is stored or can be stored in your computer. It occupies the space in your computer, right, in your computer system. But what if you do not have enough space in your computer? You cannot download even let's say 1 GB of data. Okay, so in that case, these web mapping services are useful. Okay, because they work on the remote server. You do not need to save it in your computer to load it in a QGIS or any GIS software. You just directly provide a URL and everything will be loaded in your workspace. Okay, so in this way the data is stored remotely, right? And you can use them as a base map. The disadvantage is that you cannot with WMS, the disadvantage is you cannot perform any processing. They are just your JPEGs. Okay, they are just in like your pictures, or you can use them as a base map. Now we will see how we can get this web mapping service or web map tile services, which is hosted on a remote server. Okay, so this is kind of similar to a website. You can access it as long as you have internet connection, or you have connection to that server. Okay, so using QGIS we can load WMS directly into our existing map. Um, let's load one WMS layer for the same area. Okay, and for this I will use this Bhuvan website, which is your which provide your several thematic maps. Okay, and the good thing is that they provide these web services which we can directly use it in our QGIS, right, or any other software like ArcGIS. Okay, I'll provide you this link in the chat box. If you want, you can try it. Now, yeah, with this website, we want to get our WMS data. Okay, and for this, first we will select the theme, and let's say I want to get this land use land cover at the scale of 1 is to 50,000 between 2015 to 2016. Okay, yeah, for state, because we are working in Tamil Nadu, and I'll go with this. I'll click on view. So see, it has loaded, because now we want this layer to be loaded in our in QGIS. Okay, so if you want, you can zoom into this particular district. Otherwise, it doesn't make much difference, right? So let's say I went to this Chennai region. Okay, then you can go with the statistics, state-wise statistics. You can see, okay, this is 90.54% is the built-up area in Chennai. Okay, and let's directly go to this web services, which is more important for us. See, they have given us the URL. Okay, so you copy this URL from here, copy this and go to QGIS, go to data source manager. Okay, open data source manager. Okay, here you will find this WMS WMTS option. Okay, this option. Okay, I'll remove my previous one so that we don't get confused. Right? Okay, so click on this WMS WMTS option, click on new, okay, and go to URL, click the URL, give it any name of your choice, and keep everything as it is. We don't need to change anything here. Click on OK. Okay. Also make sure that your EPSG 4326 is matches with the EPSG given here. Okay. So these are same. So next we want to know, we want to get this particular layer. Okay. So copy the layer name from here and yes, connect it. Okay, it will give you the list of all the layers present in this particular website. Okay, so see, there are so many layers that are present. Okay, you can load any of them. Just find out whatever is your interest. But if you want that particular layer of LULC in Chennai, then like paste this name here. Okay, in this filter option. Okay, so you got this layer, right? So it is giving you some information. So click on the layer. So it takes some time. Again, it will take some time here. It will get highlighted once it is done. So there are different type of image formats. Okay, just check which image format it is supporting. It is supporting this PNG format, so keep your data in .png only. Okay, so it got selected, and after this, if you want, if you think you have to change this EPSG, this, sorry, CRS, then you can change. Otherwise the data is in your 4326 format, so keep it as it is. Okay, and after that click on add and click on close. Okay, it will take some time again to load. Yes, it will. Yeah. Okay, when you want to get to a particular layer, right click and click on zoom to layer. Okay, so it is processing. Can you see this blue thing here in the task, in this bar? Okay, it takes, yeah, see, it got loaded, right? But and if we want to see this WMS layer in this particular area. So as you will zoom in, the good thing about this WMS layer is that if you will zoom in, it will refresh its view. See, when I am zooming in, it is refreshing its view. Okay, so it looks like that it is made up of vectors, but it is not. Okay, it is all raster, right? So it has a very good resolution. That's why it is not easy for us to see the pixels. But when I'm zooming in, can you see these pixels? This is because this shows that this is a raster data. Okay, the disadvantage is again that we cannot change its symbology. Whatever it is, we have to adjust with this only. Okay, you can use this legend in your map, right? So it is a map similar to a normal map that you see on paper or that you receive as an image. Okay, so it is taking time to refresh its view depending upon the internet again. Okay, so I think we are done with the loading. I have demonstrated here that how you can load your data, raster data, different type of raster data, which is already present in your computer or which is not present in your computer. Okay, if you want something from the from the internet or from the different server, then how you can? There are some of the options which you can use here, right? These XYZ tiles are even your .png format. Okay, and you cannot make changes. Sorry, you can edit some changes here, but you cannot do some type of processing. Okay, you cannot change its symbology. The disadvantage of this OpenStreetMap is, but you can of course extract the data as we discussed yesterday using one quick OSM plugin, right? So this is the final words from my side. But one more thing, why raster data are important and what are the advantages? I'll close my words by discuss after this advantages, discussing the advantages of raster data. So advantages is that your raster data is compact and very efficient for storage. Okay, it suits for large data sets covering extensive regions. So if I will ask you to prepare, let's say, one picture, okay? If I'll give you one picture, let's say this picture, okay? Will you be able to create, every element? Will you be able to extract every element in this? No, it will be very difficult. It will be lot of work to extract every element using vectors, right? So that's why if you want to represent your large data sets, your rasters are very handy and very compact. Right. So rasters can act as base maps. They can act as thematic maps, as we saw land use land cover map that we downloaded from Bhuvan website. This is a powerful format for advanced spatial and statistical analysis. So the ability, what is the ability to represent continuous surfaces? Okay. So even that Google satellite image, we saw that everything looks continuous in the pixelated form and perform surface analysis. They have the ability to uniformly store points, lines, and polygons, which is not with the with your vector data. Vector data doesn't look real. Okay, vector data is actually a drawing that that we are tracing, so it doesn't look real. So, and it doesn't have continuous surfaces, right? So the ability, it has the ability to perform, with fast overlays with complex data sets. Okay, fast operations with complex data sets. So I think we have made something clear about raster data sets. What are they? How do they look like? What are their advantages? How we can load raster data, right? And what are the different sources using which you can load raster data? Different themes, right? They have these lineaments, these flood hazard, flood annual layers. You can get this data, but they are all in the WMS. They all are in WMS. Okay, so you cannot make any edits. You cannot change the symbology. You can just use them as a base map for, let's say, if you are writing a research article or if you're writing a new project for NPDF. Okay, so and you want to show your study area in which you want to work with the land use land cover classification map. Okay, so this is the one that you can use. This will be very useful for there, you because you just want to show your area of interest and the land use land cover over there, right? And in the same way, if you want to use the geomorphology, you can use this as well. Okay, let's say if they have data for Gujarat. Okay, and I'll just view it. Yes, see, they have got the data WMS layer in and geomorphology for Gujarat. And here you have the metadata if you want to see the extents and what datum or spheroid they have used. Okay, and if you want to read who prepared the data, original source, if you want to give some credits, okay, you can use this metadata here. And when you want to use this as in your QGIS, what you do, you just directly copy this link. Okay, so this is the same link that we used for LULC. Okay, let me copy this link again, and I'll go to this data, open data source manager. Okay, and I will, let's say, let us create one more new link, and I will give it geomorphology. Okay, geomorphology name. Click on OK, connect, right? See, you have got all these layers, and which layer, what is the layer name? Because there are like thousands of layers. I mean, you don't want to, see, look at them, look at every layer. You just want to filter them out. So just copy and paste this name, and you have got the layer that you wanted. It will take some time. Yeah, And after this, if you want, you can adjust this EPSG, but the data is in this WGS84, so just keep it like that only. But when you are using other WMS services, make sure that you change this. Okay, sometimes they are using different EPSG codes. Okay, so make sure you change it here. Right, so after that, click on add and then click on close. Okay, it's going to take some time. Yeah, right click and zoom to layer. Yeah, see, you got the geomorphological map of Gujarat. Okay, Clim, okay, World Clim Data. This is a very nice website where you can get historical climate data. Just click on this download button and it will give you the data on global climate and weather data. Uh, See, here you have historical climate data, historical monthly, and all this data is present. Okay, and they have also defined like for 30 seconds this is approximately 1 kilometer square grid, 1 kilometer by 1 kilometer. So this is the data present here.